All
All
right.
right.
Welcome to
Welcome
United
to United
Astronomy Clubs
Astronomy
of New
Clubs of New
Jersey.
Jersey.
We
We
are now
are
into our
now into
winter
our winter
season,
season,
where
where
we
we
are
are
closing up the
closing up the
observatories for
observatories
the
for the
public for the
public for the
winter.
winter.
Let's face it,
Let's face
it's
it,
no fun
it's
to
no fun
park in
to
a
park in a
snowdrift,
snowdrift,
and it gets a
and it
little
gets a
bit
little bit
cold this
cold
time of
this
year.
time of year.
That being
That being
said, I
said,
do want
I
to
do want to
welcome
welcome
everyone who's
everyone
joining
who's
us
joining
on
us
both
on both
YouTube and
YouTube and
Twitch.
Twitch.
And I
And
cannot
I
listen
cannot
to
listen to
myself that
myself that
loud.
loud.
Okay, sorry
Okay,
about
sorry
that. I
about
needed
that.
to
I
change
needed to
that
change that
up a little
up a
bit.
little bit.
Um,
Um,
so I
so
do want to
I do want to
thank everyone
thank
who's
everyone
made
who's
that
made that
this
this
2025
2025
winter season a great event, and as well as all our volunteers who have made our public programs possible. So, uh, normally, because we would be on site, I would do the whole safety spiel. We can skip that tonight and get straight into uh, me recommending that you uh, do check us out on our website, uacnj.org. It's where you're going to find a list of all our upcoming winter talks that we will have online. Some of them throughout the winter will be reruns because that gives us volunteers a little break from being in front of the camera and allows us to work a little bit more
a little bit
behind
more
of.
behind of the scenes and to actually get some extra products to get the next season uh, un- underway and bring new improvements to the programming. You can also follow us on our social media, our Facebook, Instagram. We have a Discord server, all great places to get in touch with us, find out what we're doing, as well as if you have any questions or just want to share this neat thing you saw in the sky, excellent place to do that. So, with that, our talk tonight is What's Up in the November Sky. Normally, this would be presented by Lonnie Bunis, but as he had other um, engagements that were unavoidable, uh, tonight we actually have Paul Fischer doing the talk for us. Paul Fischer has a Bachelor in Engineering and Chemical Engineering from Stevens Institute of Technology and has worked in the environmental and chemical industries. Those always interested in celestial objects, Paul's official start in amateur astronomy was one night many years ago lying in awkward positions on his roof, much to the chagrin of his wife, I'm sure, where he caught a brief glimpse of the Galilean moons of Jupiter, and from then he was hooked. He's now an active member of Northwest Jersey Amateur Astronomers and volunteers at UACNJ. He still finds time to find himself outside at night, freezing cold in awkward positions, seeing neat stuff in the night sky. And with that, here is Paul.
Thank you, Kim. Hello, everyone. And this first slide here is mostly irrelevant because, as Kim said, we are in our winter season and the observatory is currently not open. However, I do want to point you, are a completely volunteer organization. I'm pointing you at that second bullet point there. If you go to our website, and there is a menu choice, a link to where you can PayPal and other ways of donating to our sites, to our organization. Uh, then please, if you find any benefit in what you hear tonight, or you've visited during the year, or just feeling extra generous today, if you could make a donation to us, that's always appreciated. We do run as a volunteer organization, and our budget could always use the help. All right, so moving on to what we're doing tonight. what's up in the November sky. Lonnie very humbly put my name up there on the byline first. However, Lonnie did most of the work on this presentation. I added a couple of things, changed a couple of things, but Lonnie did most of the work. So Lonnie gets full credit on this, and I'm just giving him an assist tonight because he couldn't make it. So if everyone could, give Lonnie all the credit, and if there's any mistakes, then I'll take credit for those. And skywatching events, here's just some references, some links, and these are live links in my presentation, so I'm not going to click on them. But these hyperlinks here would bring you to a place where you can get some of the information that Lonnie aggregated for us and put in this presentation. All right, so what are we going to talk about? Well, first we're going to talk about the meteor showers. You can see two of them there up there on the schedule. Also, let me just run through everything once before we start. We're also going to talk about the moon a little bit. We're also going to talk about Uranus, and then we'll talk about T. Corona Borealis, and maybe a couple of other things along the way. But Lonnie likes to highlight the things that change from month to month in the sky, and so these are those major things. And then we'll talk about some other cool things you'll see in the sky too. So first is those meteor showers, and going back here, we're talking about the Taurids and the Leonids, and you might recognize those as constellations, and indeed those are constellations. So here we have Taurus the bull, and here we have Leonids, the lion. And so we are going to talk a little bit about what these symbols mean, radiance. And we will address that as we go through these meteor shower slides. First of all, there are two torrid meteor showers. There's the southern and the northern. They peak at different times during November, November 5th and November 9th. They don't have very definite peaks, but that's their as in as in the contrast of when they start versus when they finish versus the peak. The number of meteors you see is not the variation in the number of meteors you'll see is not stark. When to watch, it's best after midnight, before November 5th, after the waxing gibbous moon has set or is lower in the west. The duration, the full meteor shower happens in the south from September 23rd to November 12th. That's south in the sky. You don't have to go anywhere to see you don't have to go travel to the south anywhere to see them. And then the same with the north, in the northern part of Taurus. From October 13th to December 2nd is the duration. The radiant rises early in the evening and is highest around midnight. And the nearest moon phases, the full moon is November 5th, and the last quarter is November 12th. What is that telling you? The moon is a beast in the sky, just as the sun during the day is a beast in the sky. In fact, the sun's such a beast, it blots everything else out except occasionally the moon, right? The moon in the night sky, especially when it's full, will tend to blot things out close to it. And as it's full, blot out larger and larger areas of the sky. You can still see some things because the moon's nowhere near as bright as the sun. But when the moon is full, it's actually difficult to see these type of events. It's not great viewing for the events when the moon is full. The number at peak, and what this is this is a rate. It's 5 to 10 per hour. That is not a great meteor shower. You have to wait around for the meteor to show up. There is a note that Lonnie included here that these tend to be slow moving, but sometimes very bright meteors through the sky. What that is it's a larger chunk. Most of these things are dust-sized particles. When you see something bright streak across the sky, a fireball would tend to a larger chunk that actually hits the atmosphere and burns up in the atmosphere. So those are always spectacular when you look up in the sky and see them. We see them occasionally, on our public nights at UACNJ. Now, what's the idea of this radiant, and why is the timing slightly important? You see here the north torrid radiant and the south torrent radiant. If you envision the path that the parent body, the comet most likely, or the asteroid that passed through Earth's orbit, it left a trail, a 3D trail that one could think of, say, as looking down the barrel of a gun. Or if you want to be a little kinder, say, looking into a water slide. And so that is left a 3D path in the sky where that parent body went through. So what's happening there is that Earth is passing through that radiant barrel, or that radiant 3D slide, or uh, through the radiant in the sky. And so what happens is that if you catch the meteor shower as it's setting or rising, you're only looking at half of the possible uh, uh, meteors from that shower, because some of them you're missing, they're going underneath the Earth. So if you wait until the radiant rises, you get to see more of the shower. Some of them are going to pass below you, some of them are going to pass above you or to the sides, and you want to see as many of them as you can to get your best view. So that's why you want to take the time to the suggested times to view the shower a little bit seriously. You want to wait until that radiant is prominent in the sky. And here are the Leonids with there's Regulus, a very famous star in Leo, and that has a large radiant there, and it is predicted to peak on November 17th. And when you should watch it is late November, November 16th. Well, anytime in late November. The duration is from November 3rd to December 2nd, and the radiant rises around midnight and it's highest in the sky at dawn. The nearest moon phase is a waning crescent, so the moon will probably not interfere with the Leonids. Unfortunately, it's also not the best meteor shower. It is, but it's better than the Taurids at a rate of 10 to 15 per hour. So, how do you view it? Well, very important that it's an all sky, for you to know that it's an all sky event. You can see the meteors appear to come from the radiant point. However, they can be anywhere in the sky, streaking away from the radiant. And so you don't want to really concentrate too much on using equipment during during a meteor shower if you want to see and appreciate the meteor shower. However, Lonnie has suggested that a blanket with a comfortable chair might be appropriate, and at this time of year, I thoroughly agree. Looks like he has some information there on a cooler. So he's suggesting that you have a beverage with you, and that doesn't sound like a bad idea if you're so inclined, and maybe some information on where to find the constellations, for instance, the atlas that's pictured there, and then maybe some photographic and flashlight, so you can take any pictures of you. You probably won't catch the meteor unless you're taking some sort of time lapse photography, or but you can do that if you're skilled at that, and then maybe some flashlights for some safety. So don't worry too much. There's binoculars there. You can use those if you happen to catch a larger meteor shower with a lot of meteors coming. But also, don't worry so much about not having a telescope or anything like that. This is really a naked eye type of event. All right, so moving on from meteor showers, we're going to move into the moon phases. And here tonight, we have almost a full moon. The illumination is 80% of the moon's near surface. And it's this phase, this shape on the moon that is pictured here is called a waxing gibbous moon. The An alternate name for November 5th's full moon is the hunter's moon. It is a supermoon. The supermoon is don't a little bit of a red herring in the sense that super greatly exaggerates the effect. Super means that the moon is slightly closer in its orbit to the Earth. It'll appear slightly larger, but if I'm just doing this off of the top of my head. I think it's like a few percentage points, if that much bigger. So very difficult to notice with the naked eye. It's not that much bigger. However, it is a little bit closer to us, so it should appear slightly larger, which is why it's the super hunter's moon. Now, here is the full story of the moon this month. The 5th is the full moon. The 12th is the last quarter, which you have to think about a little bit to understand why it's the last quarter. The 20th is the new moon, and then the 28th is the first quarter. Now, let's go into the terminology there a little bit. Full moon's obvious. The new moon's also obvious. It's the beginning. So that's why the first quarter happens after the beginning, the new moon. So that's why we're getting the last quarter. One would think immediately the full moon is zero. It's not. The new moon is zero. And then the first quarter is, say, one. The full moon is two, or one half. And then the last quarter, the 3/4 of the way through, is the last quarter on the 12th. And that's why it proceeds that way. And why is it that way when obviously the 12th and the 28th, the last quarter and the first quarter, is obviously half of the near surface of the moon is illuminated? Why is that called a quarter? Well, it's because you have to take into account the full cycle of the moon. Look at the 13th through the 23rd here, the 13th going through all the way to the 23rd, and all those darker phases of the moon also count as part of the cycle. So you have to take those into account. So, in other words, it isn't talking about the illumination on the near side of the moon, it's talking about where the moon is in its total cycle. And that's why the last quarter and the first quarter is, say, a little bit misleading at first. You have to think about the total cycle of the moon, not the percentage of illumination of the near side of the moon. And just as an aside, why am I talking about the near side of the moon? If you remember that the moon is tidally locked to the Earth, that means that the uh, the cycle of the rotation of the moon is the same as the cycle of the orbit of the moon around the Earth. So the moon spinning on its axis and the moon spinning around the Earth happen at the same speed, rotationally, and therefore we always see the same side of the moon, and astronomers refer to that as tidally locked. Okay, here's another event. Uranus is at opposition. First of all, let's talk about what, sorry, I'm advancing there and I wanted to go back. What is opposition? Opposition is when the planet is directly behind us, when the sun is directly in front of us. So it's a line, sort of, mostly, the sun, the earth, and then the planet is behind us if we are facing the sun. Uh, so we would actually be facing the planet because it's nighttime and we are looking at it, right? So we are interested in seeing the planet at night. So the sun would be directly behind us. And that's what opposition is. So the opposition is only possible for uh, six, excuse me, let me do the math real quick. Yep, six of the planets, excuse me, the they are the outer planets. The inner planets, Mercury and Venus, do not have an opposition. So that only happens to the outer planets because they're the only ones that can be behind us directly behind us during a year rotation around the sun. So there is Uranus. This is a stellarium program, and it is in the Taurus at that point. And Lonnie has it labeled and circled there. And so that's kind of cool to see that, where it is. Stellarium is a cool program. It also allows us to see this. This is Uranus you can see the color, which is, say, a cyan. It is, if you see it in a telescope, you don't get to see it as big as shown here. You would need a space telescope or a flyby or some sort of interferometry to see it that large. Maybe someone's has a big single scope you can see it that large in. I'm not sure, but certainly at telescopes that aren't that only researchers have access to. Uh, Uranus is just a small dot that you can barely what's called resolve the disk. You can see it that it's bigger than a star, that it's actually a circle instead of a point of light. However, it does not appear big with large details like is shown in this slide. Uh, but you can resolve the disk in a telescope. The way you really can tell that it's a neato object is that cyan color stands out like any amongst everything in the background. So that cyan color is really neat. What also is shown here is a lot of Ornis's moons. So Miranda and Ariel and Puck and Juliet. So and Titania. So a lot of Greek mythology there uh, uh, orbiting Uranus. So that's kind of cool. The other thing you'll show, and did I just go backwards somehow? I know I went forwards again. And so, no, what's happening here too is that, and Lonnie's going to show us in a neat slide in 2 slides from now, I think. Maybe it's the next slide, but we'll see. Is what's weird is that when you look at the other planets, you can see most of the major moons lined up in a single line going straight across from the planet along the equatorial region of the planet. So why is Uranus different? Well, it's not different in that the uh, its satellites, its moons, don't line up with the equator. What is different is this, and this is cool. Uranus is at a 98-degree, where we have a 22-degree tilt in our axis. Uranus has a 98-degree tilt in its axis. So look at that. It's like facing us. Those moons are orbiting Uranus somewhere near its equator, most likely. They don't have to. They sometimes capture the big, especially the gas planets or the ice planets will capture moons that are not along its equator, but the major moons will probably orbit around the planet. That planet just the North Pole, its pole just happens to be facing at us right now, and so these moons are rotating along, say, the surface of a plate rather than along the edge. So it doesn't look like a line to us. It looks like, uh, a three-dimensional plate staring at us as they go around. Kind of cool. Why did that happen to uh, Uranus? Astronomers do have a theory about that. Obviously, we would have to go back in time to observe it in order for us to, as us being humanity, to understand that fully. However, some mathematical models seem to be, and many astronomers are in agreement that there was a planetary interaction between Uranus and one of the other planets, and had tended and it tilted Uranus on its side in its orbit. So that's the current theory of how that happened. And then T Corona Borealis, which you can see is everything else here was in the events portion of the conversation tonight. We're in order, date order. However, T Corona Borealis is a little bit special. It's got a question mark here, and we will go into that in a minute. Why are we questioning it? Well, here's what's happening over at T Corona Borealis. It's called the Blaze Star. It's actually this. Here we have a full sun, which is the companion to T Corona Borealis. This full sun, even though it's larger volumetrically, is actually the minor star in the system. T Corona Borealis is heavier. Its companion star, which is still still on the main sequence. It's not a white dwarf like T Corona Borealis. The companion is only 1.1 solar masses. That means it's 10% bigger than our sun. T Corona Borealis is more massive than that, even though it is a tiny white dwarf, much smaller than is shown on this slide. But even though the main sequence companion is uh, much larger in volume, it is lower in mass. So here is a what's happening is that the white dwarf is accreting matter from its companion star. The shape of that this star is currently exhibiting is called a Roche lobe, and it is so there's this stream coming across, and it is uh, accumulating around the white dwarf. That disk is called an accretion disk. The and the process is called accretion. So it's accumulating, but astronomers use the terminology accretion. So what's happening is that stuff is going on to the white dwarf. I will go into what causes the brightening in a minute. But what happens is that the result of that uh, additional material being added onto the white dwarf is that periodically it brightens from a magnitude +10 to a magnitude +2. That's 1,600 times brighter. You have to remember that magnitude positive numbers as they go up are dimmer, and until you get to 0, and then negative numbers as they get more negative are become brighter. So a magnitude +10 is a lot dimmer than a magnitude +2. Predictions of the next nova made by Gene Schneider in October 2024 is, first of all, that we missed. It did not happen. Yeah, the 27th of March, 2025. The next one is this month, 10th of November, 2025. Then next year, there is a possibility the 25th of June in 2026, and then the 8th of February in 2027. So here's the reference. When will the next TCRB eruption occur? Research notes of the AAS, and then there is a reference number there. So now take this all as this is theoretical calculations. And as you can tell, since it didn't happen on the 27th March 2025, there are levels of uncertainty with these predictions. So it's not a foregone conclusion. So just keep an eye on T Corona Borealis. You would be able to see this star. So let me go back here again. The arrow keys here. Uh, so what I mean with keep an eye on it, we're going to talk about a planisphere later in the program here. Use that to find Corona Borealis in the sky, and then keep an eye on it. That will be a uh, naked eye event when it happens. A star that you could barely make out will suddenly brighten to a very bright star in the sky. Probably, if I, similar to Vega or one of the really bright stars in the sky. So let's talk about what's happening. This event, this accumulation of material on the surface of T Corona Borealis and then brightening is called a nova. And let's be very careful. Sometimes you may see that scientists, astronomers included, are very fussy about their terminology. This is one where the distinction is important. This is a nova. They are two very different explosions between a nova and a supernova. One is a boom, the other is a really big boom. Big is really big? This boom, like I said, will brighten the star to a 2 magnitude instead of a 10 magnitude. A supernova, a type 1a supernova, would outshine the rest of the stars in the galaxy, not individually, collectively. So a big difference in the brightness of those two events. A nova is a nova, which this is a thermonuclear explosion of accreted matter on the surface of the remnant. The remnant will remain. So that is hydrogen accumulating on the surface. This is um, it's very ordered matter. It is the electron degeneracy has happened to create this white dwarf, and it is when matter that is not aligned with it, energy gets transferred, and that matter starts heating up. It eventually heats up to the point that nuclear reactions kick off, and the hydrogen goes whoosh, and it most of it actually leaves the star, the white dwarf. Excuse me, the star remnant, the white dwarf. A type 1a supernova is when a white dwarf goes boom, is the failure of the electron degeneracy of the remnant due to accumulation of the accreted matter. The remnant, uh, instead of that accumulating, that accreted matter uh, going nuclear, so to speak, and fizzing off into space, the star instead reaches what's called the Chandrasekhar limit. And I didn't check the spelling on that. Maybe I did. I don't double check me on everyone, please, on the spelling of that. Um, but the Chandrasekhar limit is about 1.4 solar masses. The remnant, when a type 1a supernova goes off, is completely annihilated. And because of that fact that we have this hard Chandrasekhar limit, and that event shines brightly, more brightly than its host galaxy, type 1a supernovas are what's called a standard candle, because we know what mass it occurred at, and we know how bright that object should be because we know that it's completely annihilated and all the matter that was transferred into energy. So we know how bright it should be right there on top of it. So the distance factor, now we know we can calculate distance, because distance, if you remember from your high school physics, is it varies as from an inverse square law. Now we can calculate the distance, and is known as a standard candle in astronomy. So that's cool. The other thing to remember, though, is that this is not a supernova that's about to happen. This is a nova. To Corona Borealis, just for you, just for if there's any astronomy preppers out there, there probably aren't any, but just in case. T Corona Borealis is currently 1.34 solar masses, which looks really close to the Chandrasekhar limit. It is close. But recent studies of the orbital mechanics of the system, that's how they can measure the masses of these things to understand the orbit and see how the two objects there are pulling on each other. They seem to indicate that TCRB is not accumulating matter through its interaction with its companion. Whether or not TCRB will eventually go supernova is still being debated. Some think it is a candidate for a future supernova. Some think maybe it's not. Hopefully, it would be great to see a supernova so close. And why do I say that? Well, the last bullet point explains that TCRB is about 3,000 light years away from Earth. There are no known potential supernova stars within the 160 light year distance range that would be dangerous to us. So why it would certainly be a spectacular event, with certainly that star going supernova being visible in the day sky, it would not adversely affect our planet. It would just be interesting to watch. All right, let's talk about, in general, the constellations that are up on November 15th, mid-November, so up this month. Here, if you look to the north doesn't change a whole heck of a lot. Here's Ursa Minor. This is the North Celestial Pole right off the North Star, which happens to be the last star in the handle of Ursa Minor, the Little Bear or the Little Dipper, most people know it as, right? And then these constellations circle around the North Star. They go, and I was just indicating, yes, no, this is the correct direction, this direction around the North Star. And what happens is a small circle goes around the closer you are to the star to bigger and bigger and bigger till eventually you get out here, which are really more overhead during this time of year. And all the way out here, the circle's so big that you see half of it during half of the year, and the other half, it's in the sun. And during the day, it's on the other side of the planet because we don't happen to be facing that direction. So the circles are just getting larger and larger and larger, and they only include an arc in the sky because that's all we can see of it at any one time because the circle's so large. If you change your latitude, for instance, you might notice that Alaska's flag contains the Big Dipper on it. That's because you are closer to the North Star, and the Big Dipper never sets if not all of Alaska, at least certain parts of it, and you see the Big Dipper all year round because the circle's small enough and you're far north enough to be able to see it all year. Kind of cool. In the east here, we will see Taurus coming up. These are all the guys and gals we'll see a little bit clearer during the winter. Uh, uh, Taurus the Bull, Orion the Hunter. These are very familiar constellations, and we will be able to see them. They are just rising, not great for viewing until a little bit later on in your viewing evening. But if you want to stay up a little bit later, you can get a good preview of them in the sky in November. In the West, these guys are setting. These guys are leaving for the year. And that's Cygnus the Swan. We have Aquila the Eagle, and we have Lyra the Lyre. And if you remember these three stars, if you've ever been up at the observatory right here, this is Deneb. This is Vega, and this is Altair. And these three stars form the summer triangle. And of course, it's not summer anymore, so these guys are on their way out, and we'll have to catch them late spring next year once these guys are gone for the season. But we can still catch some of them as long as we get our telescope set up quick enough at night. High south. So this is more overhead. Pegasus is very prominent and this is Andromeda this way, the constellation. Here's Pisces, and the square of Pegasus, we all call it, is prominent in the sky overhead. This is Pegasus over here. Excuse me, Andromeda over here, and this fuzzy blob is actually a object that is 2 million light years away, and you can see it with the naked eye, and it's called the Andromeda Galaxy. And so just remember, light travels until it hits something. It gets dimmer and dimmer and dimmer the further and further it goes away. Remember, it follows the inverse square law, but you can actually see an entire a galaxy's worth of light with the naked eye, 2 million light years away from with your, if you look up in the sky this point in November. And here is a closer view of Andromeda Galaxy. We've talked a lot about it. What an interesting thing, I'm not going to go into it because I'm still trying to understand it myself, is there is a paradox associated with Andromeda called the Andromeda paradox. Look that up. It'll bend your mind a little bit. So do take a look at the Andromeda paradox. Let's move on to the low south. What's interesting about when you're looking to the south and the fact that we are sitting here at the 40th parallel, or just above it here, is that you get to see some of the southern sky. The equator, uh, if you were to project it into the sky, or call it the equator of the celestial sphere, same thing, same concept, runs in this region. And so you're actually seeing in these, in the Aquarius and the Cetus constellations, you're actually seeing objects in the southern sky. That's cool. Pisces is in the northern sky above the equator. And that's because because we're at the 40th parallel, we're getting an angle underneath the equator at 0. So I looked that up. I also used Stellarium as, oops, there we go. What's going on? What did I do? Oh, I hit the touchpad. I'm sorry, everybody. Let's go back there. There we go. And here is that equator. You see the same constellations. I tried to make it about the same size, about the same position so we can understand it. Here's Cetus, here's Aquarius, here's Pisces above the equator in the northern hemisphere. And so there is the equator along here. Then there's this line, which is called the ecliptic. This is actually the line where between that the planets, the outer planets in this direction, and the inner planets and the sun lie along our in the plane of the solar system. So this is significant in that our equator is, you're seeing that 22-degree difference right here, that 22-degree difference. What is that? Alternate interior angles? Oh, you thought geometry wouldn't do anything for you. So the ecliptic and the equator have a 22-degree difference between them. And so this point here, what's neat in this view that Lonnie had of the low southern sky in November is this point is in there. Anyone want to guess what that is? You don't have to guess. So I tried to line up the sun for some strange reason with that point. And my first guess was to use this date, 9/22/2025, which happens to correspond to the beginning of autumn. But let me go back again. You can see that's not the point that Lonnie had picked out, right? That's not that's Virgo there. That's Libra. This is a different point in the sky, not the same place. This, however, you can see right here, Cetus again, Aquarius, and Pisces, this is our point. And so what that is actually, I put the sun again at that point, and this is called the equinox, right? The seasons change for autumn and spring on the when the sun lines up on that equinox point. So don't think of the equinox just as a date. Also think of it as a point in our solar system, a point in our Earth slash solar system, the way those two different systems interact, uh, in that those points actually exist in space. And when the sun just happens to line up with them is when the equinox occurs. And it's also worth knowing, some prefer the March equinox and the September equinox, because what's the vernal equinox for most of us, for the southern hemisphere, and when I say most of us, most of the population does happen to live in the northern hemisphere. For the southern hemisphere, this would not be the vernal equinox, this would be their autumnal equinox, because they're going into at this point, when the sun's there, they're going into autumn while we're going into spring. Lonnie, so and I think I got that a little bit out of order, but that's all right. We're just going to talk about, we were talking about Uranus before. Here's Uranus here. This looks like Uranus again to me, just because of the color. Neptune is more of a cerulean blue type of color. Could be Neptune here, but I'm thinking that's just Uranus again. Here Saturn is also up. Um, and here's Saturn's moons. You can see that the rings are edge on. You can see that those major moons of Saturn having over 200 moons, are along the equator, just like they are in Uranus, but they they look like a large glob. They're actually circulating around, but the plate is face on. Here, the plate is edge on to us. And so the major moons lie along the equatorial plane. To get a little bit more clarity there on what was meant, is here is the moon. Actually, tonight, here is the moon, here is Saturn, and here is Neptune right close to each other, all lying in that equatorial, excuse me, in that ecliptic plane, just about in the sky, and right where we expect them to be, but also very close together. So if you're feeling really lazy and you want to see cool objects, you won't have to move your telescope much from place to place, and you can see all three objects and call it an evening. I saw three objects tonight. All right, and we are approaching the end here. And sorry, a lot of muscle memory going on. I have a clicker normally, and I can go back and forth real quickly, and I'm failing that on the mouse sitting here in the studio, so I apologize. So, yeah, and this, I call this slide "What's Your Function?" Maybe a reference to Schoolhouse Rock, and maybe reference to a science that really isn't a science. However, you might call that a conjunction if you so want it, if you wanted to. So don't forget, there are most of the universe is not in our solar system or an event on our calendar. Most of the universe is just sitting there waiting for you to see at the right time of year. Here are some of my favorite objects during this year that lie mostly, I think, here. Nope. Only all except two of them lie in our own galaxy. Two of them do not. M15 is the Great Pegasus cluster. It's a globular cluster, and not quite as great as, say, the Orion uh, globular cluster, excuse me, Orion globular cluster, the Hercules globular cluster. However, still a spectacular object. Take a look at it. It's a lot of stars in a globe. Really cool, really striking in the sky. M32 is Andromeda's satellite galaxy. So M31 we talked about a little bit. We saw it in Stellarium. M32 is there also, and so is down a little further M110. It's another satellite galaxy of Andromeda, and they are elliptical galaxies. They're more of a blob of stars in the sky than something that has, say, a spiral structure like both the Milky Way and Andromeda. M57 is the Ring Nebula in Lyra. And NGC 869 and NGC 884 in the constellation Perseus are each half of the double cluster. They're both open clusters. They are right next to each other. They're actually gravitationally bound, if I remember correctly. They're interacting anyway, not bound, but interacting gravitationally, and so and they also fit in the same eyepiece of your telescope. You don't have to move them at all to see both if you use wide enough field of view. And if you can do that, that's a spectacular object to see in your telescope. So anyone out there looking tonight to see a really cool object, I definitely recommend a double cluster. Those are NGC objects, so those are the catalog numbers to find them if you're using a go-to. And if you're using star hopping, they are pretty easy star hop right off of, this does say they are in Perseus, which the boundaries is probably correct in that it's in the boundaries of Perseus. Very easy to find, though, right off of Cassiopeia. And stars to see tonight are Polaris, Vega, Deneb, Altair. We talked about, I think, all four of those already. Enif is in Pegasus. Shadar and Kaf are in Cassiopeia, and Aldebaran is in Taurus. And just here's this is an astrophotography. Might look like it, it's not. This is electronically assisted astronomy. How's it different from astrophotography? Astrophotography. Astrophotographers are much more sophisticated than what I did here. I stuck a camera in my telescope and pointed at these objects for a short period of time, for shorter exposures, to gather more light, just like an astrophotographer does. But my results are not very precise. The size of the stars are not very good. The shape of the stars are not very good. I'm not getting as much light from the objects as I could, so they're not as detailed as they could be. This is just guerrilla astrophotography, and you could maybe use the analogy that EAA is to astrophotography as, say, a Kodak camera, a Polaroid camera is to regular photography. This is more of a guerrilla effort. However, it still produces pretty darn good results, and you're learning how to do major portions of astrophotography because you're still using the same things. You're just not doing it as precisely as astrophotographers do. But the devil's in the details. Don't get me wrong. Astrophotographers have significant skills that I don't have as far as some of this stuff goes. However, here's the Ring Nebula. Kind of cool object to see. This is uh, letting a little bit more light in of Andromeda. Wow, what an image! And you can see here and here It's satellite galaxies. Those galaxies are actually gravitationally bound to the monster itself, Andromeda Galaxy. And it is the monster in our local group. Andromeda Galaxy is the main galaxy. We are not. Here's Saturn. This is an older picture of Saturn. However, you do see some details on the planet, so that's kind of cool. The rings are currently edge on to us, so you see them just as a straight line going through the equator of the planet. You do not see this oblique angle that I have from an older picture. And this one's cool. This is actually at my house. This has nothing to do with the telescope. However, I went out one of the nights that we were possibly going to see an aurora, trying to get a picture of it. That never happened. But the Milky Way was going right over my house, and I thought that was a cool picture. The Milky Way, if you get an opportunity, um, the brighter portion of the Milky Way is above us, maybe even past us a little bit at this point. So get up, go outside, take a look at the Milky Way if you're in a dark area, and if you can find Cassiopeia, and if you can find Deneb and Cygnus the Swan, you will be able to find the Milky Way because it travels from uh, Cassiopeia right through Cygnus the Swan, and you'll be able to see it. That cloud isn't a cloud; it's the star from, something like 200. It's the light from 200 billion stars in our own galaxy that's coming to us, and the other 200 billion on the other side of the planet, so you won't be able to see them, but you get a good view. Nice. Some reading, Sky and Telescope, Astronomy, Space.com, all great places to take a look at. Lonnie's recommending there. Here's some reference material for you. These are all apps that you could use to find your way around in the sky. That's kind of important. You got a whole year's worth of sky to get used to if you're just beginning this hobby. These guys help you out. I still use them. I'm not saying that I have anything significant memorized in the sky. These still are all very useful, but especially starting out. Stellarium, many of the images you saw tonight came from Stellarium, so definitely get used to Stellarium. It's very feature rich. It's one of those programs you gotta, digest a little bit. So start using it, start understanding the various things you can do with it. It's a great program. And to start observing this planisphere is a simple way, a simple reference. You just there's two dials or two markings along a dial, and you just line up the date with the time, and you point it to the appropriate area in the sky, the north or south, remembering that you have to look up at the planisphere. Don't look down, because east and west don't make sense unless you're actually looking up in the sky. So look up when you're using a planisphere. Uh, Binoculars are a cheap alternative to many telescopes when you first start off. So possibly invest in some binoculars. Let's go for a review here. There's the dates on the various, we're closest to the full moon. That's happening November 5th, the various phases of the moon. And we talked about the Taurids meteor shower, the full moon phase on the 5th, the Leonids meteor shower about mid-November, the new moon happening on the 20th, Uranus at opposition, and then the possibility of T Corona Borealis going not supernova, but nova. Thank you for visiting us at UAC&J. Please do, as I said here, where is our website? It's there somewhere. Right. It's around there. on the web? Why am I not finding it on this slide?
It's the star.
It's the star. Okay, there it is. I'm sorry. Thank you very much. UACNJ.org. Please visit there. You'll find a menu choice, a link to be able to donate through PayPal or other means. Please do take advantage of that if you found this all useful. Thank you, everyone.
Uh, Joined us. So we are going to be doing a question and answer session, and the wonderful thing about online only season is I don't trip over people in the dark. But we're gonna start this off with our first question, which is how far south would you need to travel before you could no longer see any torrid meteors?
Uh, I have no idea. Good question. However, you would have to be um, so the horizon to horizon would be about 180 degrees, right? It's less if you have trees and other things around, but let's call it 180 degrees. You would have to be so that your zenith is 90 degrees away from that radiant. Uh, so that would probably, I don't know where that lies in, but maybe say minus 40. I don't know, somewhere in that range. I don't know exactly where the longitude of or the declination, if you're talking about things on the sky, is of the torrid meteor shower. So whatever that is, minus 90 degrees.
So basically, we're looking at the South Pole, and I noticed someone said I was a little bit quiet. Am I a little bit better now as far as volume? That should, I did move myself a little bit closer, so that should help. Um, our next question, and this one's a real doozy for you, uh, from Ariana. Isn't time the fourth dimension? So technically everything exists in four dimensions.
Uh, Yeah, no, that's a very good point, and one of the major cornerstones. Not that I'm an astrophysicist at all, but just I've done, a little bit of reading and sharing my interest with you. Is that not only is it the fourth dimension, and supposedly that we exist not in space, we exist in space time of Einstein's theory of relativity. We are you we are in fact all traveling at the same speed through space time, not space, that's velocity. We are all traveling at the same speed, the speed of light through space time. So that's kind of cool. You need to so it is an integral part of our existence. I've read some explanations of why we can't travel faster than the speed of the light is that it it doesn't explain the numeric value, but it explains that there does make sense that there is a limit of speed that we can travel, whatever that limit being somewhat arbitrary, I guess. Uh, Ask an astrophysicist to explain that to you. But in the sense that if you didn't have the speed of a limit how fast you could travel, in other words, if time wasn't important, if time was instantaneous, what is the point of there being space in the first place if you could just instantly bamf to any teleport for those who are not maybe familiar with comic book references. You could instantly teleport to anywhere in the universe. What is the meaning of time in the first place? What is the meaning of space if you didn't have that time factor to it? space wouldn't make any sense. You could just go there instantly. You're just everywhere is right here. So uh, space time as a continuum actually makes a lot of sense if you start scratching your noodle on, a little bit on what Einstein meant. So, uh, yeah, everything is traveling through four dimensions, and they are inseparable. They are part of one big package.
A little bit, it sort of pop filter and move the mic even closer. So hopefully they're slightly better. There's always a few fun little technical gremlins when you switch from uh, on site back into the studio. But anyhow, our next thing was I did notice one of our viewers did try and physically go to the observatory, and I do want to apologize. Like I said, we are in our online only portion of programming. For anyone who was thinking about trying to join us at our location, we will pick up with on site programs starting in April of 2026 again. And those go through the on all of them are on Saturdays and go through the October. Uh,
Kim, before you move on to a question, I just want to point out too that we do have an observer program where you volunteer and you do not have to be a well versed hobbyist in order to join to get 24. It's a great way to get started in the hobby. If you just purchase a scope, or even if you just have a pair of binoculars and want to appreciate the sky, our volunteers have 24/7 access, which is a very important reason why not only do we love showing people the stuff in the sky, but we also get to go up there any night we're not presenting and enjoy ourselves up at the observatory. So that's one reason why you might want to become a volunteer at UACNJ.
okay. So I was told moving the mic closer to what didn't work. So I switched to a different mic. Uh, Hopefully that fixes it this time. Otherwise, we will try and take care of that offline. Because I don't know what else to do besides start screaming, and that might alarm the neighbors. So I want to try avoid having the cops called for noise disturbances this close to Halloween. All right. So, uh, I also want to encourage people always check on our website, follow us on the social media, because it will have updates on what programs we're offering and anything that might happen if the state system, the state government shuts down, and then we would no longer have programs there because state forest. Um, but again, uacnj.org. And like I said, we're on Facebook, Instagram, and we have a Discord server. Uh, so our next online question. Uh, we did have a reference because you were talking about the thermonuclear engine of T. Corona Borealis, and there was the movie reference from War Games. Would you like to play a game?
Yeah, uh, different scale.
Oh, sorry, I'm trying to catch back up through the question. So, uh, the viewer that had tried to come to our site had wanted to talk to you, Paul, about sighting he had back in 2017. Um, is there a way he would be able to contact you?
I think through the through our I'm the vice president, and if you were to take a look at our website, you can certainly through our email system. Uh, my as the vice president, my email is there on our website. That's not my uh, that is the UAC&J, so it might take a little time while it's forwarded, but certainly if you could contact me through there. Why don't you reference tonight's presentation, just so I know it's you, and then we can talk further on something, a particular topic, if you'd like.
And he actually had a question. What do you think about the mandala effect?
The men, the am I talking? Are we talking about the Mandela effect, or is there another effect called the Mandela effect? I've lost track of all the internet effects at this point, so you're gonna have to enlighten me. I don't know what
It
that
could
is off the top.
very well be that I mispronounce things. That happens often when you learn words from reading and not.
I'm still gonna have to have my memory refreshed. I've heard that effect before. I don't remember what it
So
is.
he did spell it Mandela.
Okay, the Mandela effect. I
Uh,
don't. You'll have to. Well, I think. No, I don't remember. Is that something like if you don't mention? No, that's got to be a different effect. Please enlighten me what that effect is.
I have a handy internet box.
Thank you very much.
Because sometimes there's so much information and not always the memory to hold it. So Mandela.
And some of us have gray, a lot of gray in their hair and in their beard, and the memory fails from time to time.
Okay, it is a phenomena where a large group of people collectively misremember a specific detail or event. It was coined by researcher Fiona Broom, and the name comes from the widespread false memory of Nelson Mandela dying in prison in the 1980s when he actually passed away in 2013.
Yeah. So there's some instances of that happening. There was some panic about drones and some other things, and there were that happens. I mean, I think a lot of the candy safety reports that when I was growing up about people putting razor blades in apples and things like that is also attributed to that phenomenon. Eh, do 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 do. We've got Schoolhouse Rock and we've got Sesame Street well represented this evening. Yeah, no, eh, people see some of these things give you a little bit of a visceral when you see some of these things in the sky. When you see, for instance, an eclipse, or you see Saturn for the first time in a telescope, or you see shooting star go overhead, even a lunar eclipse, or you notice a planet for the first time. You don't live in dark skies. You happen to go to a dark sky and you see this bright object that seems to move with you because of parallax. In the While you're driving in your car, people get a little bit of a visceral shiver, a little bit of shake in your spine, and there is that effect. And then people mention it to each other, and then go on from there. It feeds into itself a little bit as the Mandela effect does seem to indicate that happens. So uh, seeing this stuff in the sky is kind of cool. and you're gonna feel a little bit, and I think that's what that's what you're really experienced there, is that coolness. And I see it every day. I'm up at UAC&J, uh, showing people in at the public, things in our telescopes, because you get the wow. I never thought it would look like that, when people see these things in telescopes. So that's what I think that's what most these things can be attributed to, is that that's a neat thing you don't see every day in the sky, and it's going to be memorable.
Yeah, they put in chat one of the most common one.
I'm
Is
not hearing Kim anymore.
uh you're in the same room. Oh,
There you go.
it helps if you unmute the mic. Uh, Pro streamer strats. Um, One of the most common examples of the Mandela effect, and I'm gonna exaggerate this pronunciation a little bit, but I grew up with the Berenstain Bears, and it's now spelled Berenstain Bears. And tidy cat litter became tidy cats. So we're all collectively kind of misremembering certain things. uh, Memory does weird things.
It does do indeed. It do indeed do weird things.
And one of our viewers, who actually also streams astronomy and space on their channel over at Twitch, said they use binoculars with a cell phone holder to show some people the comet A6 Lemon last night for Halloween, and that worked pretty well.
Oh, that's very neat, being able to do that. I imagine if I had set my Astro setting on my cell phone, and pointed it in the correct direction, that I think it was at least one point. I think it's down around a 10, less than a 10 magnitude now, but I think at the right time I could have pointed it in the sky, because it was almost a naked sky, naked eye object, at least up here, at least in the New Jersey area. It was almost a naked eye object in the sky, for a little bit of time.
Yeah, that's a fun thing. It also depends on light pollution in your area, which is part of why it's nice for our area for us to have the site open, because we are some of the darkest publicly accessible night skies in New Jersey. Uh, I think there's some state parks down south that have similar, but they also don't necessarily have the astronomy organization uh, taking up residence and getting that state approval to run after dark programs, because most state parks are a dawn to dusk situation, short of camping there. So that's always fun. Yes, and Fruit of Loom definitely did have a cornucopia.
Okay.
I, that was definitely a thing it had. It did. My tech guys over there saying, I'm like, yeah, it did.
It's a lot of fancy people wearing a lot of fancy underwear, I'm telling you.
All right. They asked if it's the case of with how many people remember this, how could it be a misremembering?
Yeah. So there's a couple of things. One, your brain. does not record reality. That is, um, I'm going to recommend a podcast to you. It's called uh, The Skeptic's Guide to the Universe. It is a very good science communication and uh, tool, a podcast, and also delves into a little bit on skepticism as a uh, as a branch of science, not skepticism as in a general attitude towards what's happening to you currently. All right, so critical thinking is really what its main focus is. And one of in fact, the founder happens to be a neurologist, so he's somewhat expert in the field. And he a lot of his uh, Dr. Stephen Novella, if I remember correctly, his name, and he uh, he'll be quick to point out that your brain does not record reality. Your brain is a machine that is uh, making associations in your brain to help you survive. So it is giving you a reality overview that is useful to you to do actions that help you survive. It is not necessarily recording reality directly. So you have to realize that your brain cheats. Uh, i- i- One way you can combat that and make sure that your memories and reality coincide better is to use that executive function in your brain and to uh, you know do a little bit. You don't have to do research. You don't have to understand the mathematics. You do have to appreciate the mathematics, that the mathematics are telling a story. You do have to understand that people have researched these phenomenons and understand them scientifically. Uh, So you do have to understand that that stuff is valid, and you want to double check that your brain and reality, as we can calculate it and as we can predict it, are agreeing more or less. And then you can be more confident that you remembered something correctly as opposed to your brain telling you what it needed to know to do what you needed to do at that time. So those are, and I'm not an expert at any of that. This is way even off my astronomy, any small bit of expertise I have in being an amateur astronomer. But I point you towards that podcast and similar type of sources to understand a little bit that, you know, psychological phenomenon exists and are real, and we should at least understand them, and so that we can be informed that maybe it was my perception, and maybe it isn't necessary. My perception, even though it lines up with a whole bunch of other people perceptions who are also humans who have cheating brains, uh, maybe that it's possible that this different explanation is more reasonable in this situation. I'm not going to comment about anything specific. I'm not going to comment about anyone's belief systems. That is all, something that you use for yourself. That's great. But have that alternative source and have that little bit of forebrain, a little bit of that executive function kick in and say, "Hey, I can do a little bit of a little bit of deeper dive on these things and see whether it makes sense or not."
As for people imagining seeing things like Bigfoot, uh, you're looking at a girl who didn't realize she needed glasses for a while, and her grandfather was walking up the driveway to her house, and he was dressed in all gray. And I had to call into the house and ask my sister, uh, what is coming up at the driveway? Is it a really gray bear or like Bigfoot? No, it was my grandfather. Uh, put on your distance glasses, Kim. So sometimes not being able to see something clearly can contribute it greatly. Um, not being familiar with things like bears with mange. Um, so many things can contribute to missing things. So definitely people probably saw something. Uh, but what's the favorite saying? Anything can be a UFO if you are bad enough at identifying flying objects.
But that's a thank you for introducing that topic and to maybe come from at it the other side because there were we want to make no value judgments on not knowing something, right? That which it's a very coy way of putting it, and I like the saying. However, um, there are things that we can't identify in the sky all the time. That just means it's unidentified. That doesn't mean that it's extraterrestrial, right? So we again, that's our brain wanting to assign a meaning and I need to react to this. I need to do something. This is this thing, and but hang fire. Uh, it's okay to leave it as a UFO because there are things, we point our telescopes up at the sky all the time and see things go through it. And I think they're probably mostly satellites, but not all satellite is identified nicely on our apps. Governments put up secret satellites all the time for whatever reason. And not all our apps are going to track them. And we just see these quote unquote unidentified objects go through our telescope viewpoint all the time. It's okay not to know things. It's okay. Uh, I mean, they can probably eventually be discovered if you put enough time, effort, and study into it. However, you don't necessarily have to assign a meaning to it.
Um, so I do want to ask if there are any more questions in chat. Do get those in because it looks like we're pretty much done with the questions that we had. And I just want to give other people a chance to ask their questions. Um, in the meantime, because by the time you hear this, we're a couple minutes into the future. I once again do want to thank you, Paul, for another great presentation,
Thank you.
and everyone who has joined us here on Twitch and YouTube. Uh, do hit those like, follow, subscribe, free action button. It lets us know we're doing a good job and gives us the motivation to continue trying to offer these programs uh, to everyone. Uh, and again, just like beginning of presentation, I do want to thank everyone who's came up during our 2025 season. Uh, our visitors, our volunteers, our board members. A lot of moving pieces, and all of it helped us pull off a great 2025 season. So I just want to scroll a little bit and make sure I didn't miss anyone. Does in fact look like we got all the questions. So thank you, everyone.
Thank you, everybody.
Until next time, our next Saturday is a rerun, and we're going to be doing some work and whatnot behind the scenes to try and get things a little bit better. And until next time, clear skies and good scenes.